Welcome to module 2 of production and service system planning part 1. So in the previous part, which was the part 5, we were talking about the weighted moving average. So in this part 6, we are going to talk about how we can forecast using the exponential smoothing method. So let's first of all discuss what is exponential smoothing. So it is a more sophisticated version of the weighted moving average. So that means the exponential smoothing is a kind of weighted moving average where we are going to find out the more sophisticated way of the weight. So what does this mean? Which mean a good forecasting method is always should be able to cater the changes in the data which is occurring in the most recent past. So that's why we are saying that the exponential smoothing method is a more sophisticated method because it is capturing the fluctuation in the data or the changes in the data which is in the recent past it is happening. Okay, so what it is going to assign the weight? So it is going to assign the higher weight to the current values in the recent past of the data, whereas it is going to assign the lower weight to the older observation. Okay, so and it is going to decrease those weights to the older observation exponentially. So what does this mean? So let me show you the formula. So the formula of the simple exponential smoothing method is ft plus 1, which means the next time period forecast is going to be equal to alpha. Alpha is known as the weighting factor, or you can say the smoothing constant, and this smoothing constant is always between 0 and 1 because we know that the sum of weights should be equal to 1. Okay, so where at is basically indicating the actual demand in time period t. So 1 is basically the sum of weight, and the sum of weight minus alpha is going to be the weighted value for the previous time period forecast value. Okay, so we were talking about that it is going to assign the lower weight to the older observation. So what does that mean? So if I am going to open this formula, which is ft plus 1 is going to be alpha at plus 1 minus alpha, and instead of using ft, if I am going to apply the same exponential smoothing formula, so this is going to be again alpha at, okay, uh, at minus 1 plus 1 minus alpha, it is going to be ft minus 1. So this formula is we are placing in terms in place of ft. So furthermore, if we are going to write down for the formula with respect to ft minus 1, so this is going to be ft plus 1 alpha at plus, so if we multiply this one, this is going to be alpha into 1 minus alpha at minus 1, and this is going to be 1 minus alpha, and instead of we are writing down ft minus 1, so we are once again using the simple exponential smoothing formula, which is a alpha at minus 2 plus 1 minus alpha into ft minus 2, right? So if we continue this one once again, t minus 2, so what we are going to see, the ultimately we are going to get alpha at, okay, then alpha into 1 minus alpha at minus 1, then we are going to get alpha 1 minus alpha, okay, it is going to be uh, so this 1 minus alpha is also over there, okay, because when it is going to multiply with this is alpha 1 minus alpha square, okay, and this is going to be at minus 2, and then it is going to be 1 minus alpha power 3, okay, because when it is going to multiply over here, and then we are going to ft minus 2. So what we are going to see, if we are further expanding this one, so we can see that as the time moving towards the more previous values, so the value of the alpha is going to be decreased exponentially. Okay, so the weight is going to be smaller and smaller as we are moving towards the in the previous time periods, right? let me go back. So that's why we are saying that in a simple exponential smoothing method, we are able to assign the lower weight to the older observation, which is exponentially decreasing weights. Okay, as I shown you in the recently. Okay, so that means exponential smoothing is very useful if there is a recent changes in the data is significant as well as unpredictable, instead of only the random fluctuation. So if the recent changes are significantly occurring, okay, as well as unpredictable, so the exponential smoothing method is quite a good method. And the more good thing regarding the exponential smoothing method, it require a minimum data set to predict the future value. So only three things we needed. So in order to predict the next time period, we needed the current period forecast value, we needed current period actual demand, as well as the smoothing constant, or you can say the weighting factor, which is alpha. And as we have seen from the formula that the alpha should be less between 0 and 1. Okay, now, let's see if we are going to consider the value of the alpha, then what we will get. Obviously, this factor is going to be 0 and this is going to be 1. So the next time period would be equal to exactly the previous time period forecast, which is basically we are getting that the next time period is purely based on the previous period forecast instead of the actual demand. Okay, but if the alpha value is exactly equal to 1, then this is going to be exactly 80 and this is going to be 0. So that means the next time period forecast is going to be the previous period actual demand, which is exactly equal to the naive forecast. Okay, so that means when the alpha is equal to 1, then this exponential smoothing method becomes the naive forecasting. Okay, but if we are using in between the value of the alpha between 0 and 1, so like right now I'm giving the example, if we have the alpha is equal to zero point 0.2, so then it means the formula become this one. So what does this mean is that is the recent previous value of the demand, we are giving the 20% effect on the future forecast value, whereas the previous demand values having the 80% weightage overall. Okay, remember that all the previous data having the 80% impact on the future, right? Now, if we can see that what will be the effect of the lower alpha value if we are considering, and what would be the effect on our forecast value if we are going to consider the higher alpha value. If this is a demand, and if I'm moving here, if I'm using a smaller alpha, which means such as the alpha is zero point 0.1 or near to 0, so the more smoothing forecasting value we are going to get. Okay, more smoothness we are going to get. Whereas if we are start increasing the alpha, which is zero point 0.3 or zero point 0.5, so the higher the alpha value is, more you can say more significantly occurring the changes in the data. So that means if the data is changing more frequently, okay, and then the higher alpha value is going to be a good approach, but smaller the alpha value is indicating the more smoothness you would like. So in other sense, you can also say that if your data having lot of variation in the data, then we can try the higher alpha in order to predict that data values. Okay, whereas if your data do not have so much variations, then smaller alpha is the more the appropriate one, because it is more going to get the smoothing forecast value, right? Now let's try how we are going to apply this simple exponential smoothing method. As we know that the formula is ft plus 1, so that the next time period forecast is based on alpha at plus 1 minus alpha ft. Okay, so in order to predict the month of February, so I needed the forecast value for the month of January, which I do not have. So what I am going to do is, so I am going to skip this January, okay, and I am going to applying the naive forecast approach in order to forecast the February, because while using the simple exponential smoothing method, I need three component values. One is alpha, another is the actual demand of that time period, as well as a forecast. So for the month of January, we do not have any forecast value. So what I am going to do is I am going to skip this one. So I'm going to apply the naive approach to forecast the value of the February, which is going to be equal to the last month's actual demand, that is 36. Now from March to onward, we can apply the simple exponential smoothing method because all the parameter values we have, like AT as well as the FT we have of the last time period, as well as the alpha. Right now, I am saying that we are going to use alpha zero point 0.1. So that means you can use any random value between 0 and 1 to take the alpha. Okay. So as we have seen on the previous slide that if your data having so much fluctuations, so you can use the higher alpha. But if your data do not have so much fluctuations, then you can use the smaller alpha because it is going to give you the more smoothing values. Okay, which mean if your data do not have so much variations, okay, smaller variation, try to use the smaller alpha. But if your data having so much variations, then you can use the larger alpha. Okay, so in order to forecast the value for the month of March, what we are going to use, so the alpha is zero point 0.1. Okay, multiply by, we have the actual demand. So what is the actual demand for the month of previous month, which is a February, that is 42, plus 1 minus alpha. So 1 minus zero point 0.1 is equal to zero point 0.9, multiply by what was the forecast, which is the 36. Okay, so we will get the forecast value for the month of March. Same is the case in order to get the value for the month of, you can say, April. So what we are going to do is, so that is going to be zero point 0.1 multiplied by the actual demand for the month of March, which is 56, plus zero point 0.9 multiplied by whatever the value we are getting of the forecast value for the month of March, and then we would be able to get the forecast value for the month of April. So same is the case if I would like to predict over here. So I needed the forecast value over here. So let's say that is this tick mark. Okay, we have this forecast value. So how we are going to calculate, that is zero point 0.1 multiplied by 110 plus zero point 0.9, which is 1 minus alpha, multiplied by this one, and then we would be able to get the forecasted value for the month of January. Okay, so you can you already know how to find out the error. So that is the actual demand minus the forecasted value. You already know how to calculate the absolute error, error square, absolute percentage error, and how you can calculate this one. We have already discussed in our previous lectures. Okay, so you can try when the alpha is equal to zero point 0.5. So what I am going to do is I am going to apply when the alpha is equal to zero point 0.1 and when the alpha is equal to zero point 0.5. Okay, I am going to use with the help of Excel. So in Excel, I am going to use the same case study which we were discussing. Okay, uh, from the while we will start discussing the forecasting lectures. So here we have the data set, which is 2 years data, 2018 as well as 2019, and we are going to predict January 2020. Okay, so once again, in order to find out the forecast value for the month of February, what I am going to do is I am going to apply the naive forecast method, which is going to equal to the last value, last month value, and then we are going to apply the formula which is equal to zero point 0.1. So that is the alpha we are using. So I am making it absolute by using the dollar sign. Okay, multiply by the actual demand, which is 42, plus 1 minus this alpha multiply by the last time period forecast. So once we have applied this formula, so we can simply drag and drop. So once again, remember that the simple exponential smoothing is the more appropriate method when you have only the level pattern in your data. If there is a trend or the seasonality, then you cannot apply the simple exponential. So it is the more appropriate one when we have only the level component. Okay, so that means we can only predict one period ahead. So if you would like to predict two period ahead, then this value is going to be repeated, which is 94. If you would like to predict March, so that will also be 94 while we are sitting in the month of December, right? But right now our objective was to predict the value for the month of January. Now, in order to calculate the error, how we can do that? So simply we are going to actual demand minus the forecasted value, and then we can drag and drop. So this is the forecast errors. In order to calculate the absolute error, because with the help of this one we are going to calculate the mean absolute deviation. So first of all, how we can calculate the absolute error? By using the formula of Excel equal ABS, which is absolute, and this cell, and then we can drag and drop. Okay, and then we are going to calculate error square of these errors, so equal this error square. Okay, and once again we can drag and drop. So this is the error square, and in order to calculate the absolute percentage, so I make it the percentage. Okay, and then what I am going to do is, so the absolute error value divided by the actual demand, right? So then we can drag and drop. So we are going to get the absolute error, right? And then I am going to calculate the mean absolute deviation, which is nothing but the average of these values. Okay, so this is the average of these values, whereas the mean square error is the average of error square values. Okay, whereas the mean absolute percentage error is the average of these values, right? Furthermore, I have also calculated the standard deviation of these forecasts, okay, using the formula STDEV, the standard deviation. So what's the purpose of this calculating this one? So we will see that when we are going to use the smaller alpha compared to the larger alpha, you will see that there will be the less standard deviation value while we are using the smaller alpha compared to the larger alpha. So the same thing, if instead of applying zero point 0.1, if I'm using zero point 0.5, okay, so what will be effect? So let me show you. When I'm using zero point 0.5, so we are going to the same pattern we can adopt, and we are going to use these getting these values. So let me compare over here. So from here we can see that when we have the alpha is equal to zero point 0.1 and when we have alpha is equal to 0.05, so what we are going to get, so here we have we can see that uh, so this is not 0.05, this is actually 0.50. Okay, so when we can easily see that when we have the in this data set, when we have alpha is equal to zero point 0.1, so what's the standard deviation? When we have alpha zero point 0.5, so what's the standard deviation? As we have seen, uh, already discussed, that smaller the alpha, lesser the standard deviation, more smoothness in the forecast value. When we are going to use the larger the alpha, so it would be able to capture the most changes in the data. The forecast value would be able to capture those changes. Okay, but as far as for this particular data set, if we would like to see what alpha value is the more appropriate alpha value in order to predict this actual data set, so for that we are going to compare these measure of forecast accuracies. Okay, so we can see that against all the measures of forecast accuracies, when we were using the alpha is equal to zero point 0.5, we are getting the smaller measures of forecast accuracies. So we can easily say that so while we having the alpha is equal to zero point 0.5, we are going to able to get the more accurate forecast compared to when we are going to use the alpha is equal to zero point 0.1. But right now we were talking about the alpha. We were taking the alpha randomly, or you can say based on knowledge or the based on the experience about the data. Okay, and we were picking randomly the value of the alpha. If I would like to find out what should be the optimum alpha value, if my objective is that I would like to minimize the mean absolute deviation or mean square error or mean absolute percentage error, how we can calculate the optimum value of the alpha. So for that, once again, we can apply the nonlinear programming model. So the objective is I would like to minimize either the mean square error, either the mean absolute deviation, or the root mean square error or mean absolute percentage error. So whatever the objective function you would like to take, okay, whichever the value you would like. So we can consider one at a time, okay. And I would like the alpha value should be less than or equal to one, and it should be non-negative. So by applying this formula, how we can find out the best optimum alpha value in order to minimize these forecast error values. So for that, let me make it zero. So remember that because ultimately our objective is to find out the alpha. So I would strongly recommend, obviously, first of all, you should get the apply these formulas. So how you can do that? So you can simply copy it and paste over here. Okay. So we have already applied the formula. Now our ultimate objective is to find out the optimum value of the alpha. So how we can do that? We can once again go to the data and click on solver. So if you haven't seen this option, the solver, as I mentioned earlier, so how you can get it? File, options, go to add-ins, and then make sure in a manage we must have the Excel add-ins. Click go, and then make sure you have clicked on solver add-ins and press OK, and then in the data tab you would be able to see this solver tab. Okay, so in a solver tab, what we are going to do is, once we get this window, in a set objective, so which measure of forecast accuracy you would like to minimize? So I whether mean absolute deviation or mean square error or mean absolute percentage error. So right now I'm going to take that I would like to minimize the mean square error. Obviously the others are also going to be minimized. Okay, so minimize is my objective. Changing cell mean, what is the decision variable? So I would like to store the value of alpha over here, that is the my decision variable. And I would like to add a constraint that this alpha value should be less than or equal to 1. Okay, and there is no need to add another constraint which is alpha is greater than or equal to 1. So instead of using that one, we can click over here that make sure all the variables are non-negative. Because it is a non-linear programming, so we are going to pick non-linear, solve, and press OK. So it is saying use the value of alpha is equal to 1. Okay, instead of 0.1, okay, or instead of zero point 0.5, okay, use the alpha is equal to 1. You would be able to minimize the mean square error as well as mean absolute deviation as well as mean absolute percentage error. As you can see over here, the mean square error, when we are using the optimum alpha, which is 1 in our case, we are getting 62. While we were using zero point 0.5, it was 136. While we were using zero point 0.1, it was 895. So that means the best alpha value for this data set is going to be 1. Okay, so this is how you can use the Excel solver to find out the best alpha value. Okay, so once again, as we were discussing regarding the simple exponential smoothing, what was the effect of the smoothing constant, which means what is the effect of the alpha? So higher the alpha, it is the more sensitive forecast that would be able to get the changes in that most recent data set. Okay, and smoothing will be less. So that means that is going to be straight line, not the straight line, but getting the exact fluctuation in the data. So closer to the zero, so which means the smaller the alpha, it is going to give us the greater smoothing, which means more straight line we are going to get. Okay, and most commonly the value of alpha we are using between this range. Okay, so the simple exponential smoothing having the direct effect with the simple moving average. So what is the effect? So remember that larger the number we are using in the moving average, like 2 months moving average or a 3 month or a 4 month. So the larger the number, instead of 2 to 3 or 3 to 4, so it is having the same effect if we are using the smaller alpha. So how we can calculate that alpha? That we can calculate 2 divided by n. N is basically indicating the number of time periods. So that means if we are using in a simple moving average 3 month moving average, so instead of applying 3 month moving average, if I am going to applying the simple exponential smoothing method, when the alpha is equal to zero point 0.5, you are going to get the same answers. Okay. uh, so the same effect we are going to get. Same is the case, n is equal to 5. So the alpha is equal to zero point 0.3, n is equal to 9, the alpha is equal to zero point 0.2. Okay. So in simple words, what we are saying that, so the forecast with both smaller n and the larger alpha. Okay. So if I am using the larger alpha value, or if while we are applying the simple exponential smoothing method, or if I'm using the larger n while I'm applying the simple moving average, both are going to reflect the most recent changes in the past data, and it is going to reflect in your future forecast value. Whereas if I'm going to use the larger alpha and the smaller n, or smaller alpha, okay, larger n, smaller alpha, so the more smoothness we are going to get in our forecast value. So that means smaller the standard deviation or the variation in our forecast values. Okay. So there is another way to explain this simple exponential smoothing. We know this formula. If we simplify it, so what we are going to get, alpha at plus, if we multiply this one, this is going to be ft minus alpha ft. So that means we can write down this one is like this one. So that means we can say that, so the future forecast in the according to the simple exponential smoothing method is going to be the current period forecast plus the weightage, or you can say the percentage of the forecast error of the current period. So this is another way to explain it here. I hope you got the idea. So how we can use this simple exponential smoothing method to forecast the future value. Okay. So thank you so much. See you in the next video.